inductance calculation of three-phase transmission line with unsymmetrical spacing and untransposed line. So what do you mean by unsymmetrical spacing? So if the distances between the three conductors are not equal, we call it as unsymmetrically spaced conductors. So let us consider the three conductors of a three-phase line A, B and C. Since the distance are not equal, we take D12 as the distance between conductors A and B, D23 as the distance between conductor B and C, and D31 as the distance between conductor 3 and 1. So let IA, IB, IC be the currents through the conductors A, B and C respectively, and let R be the radius of the conductor. So flux linkage for a particular conductor will be due to its own current as well as the currents in the other two conductors. Hence, the flux linkage of conductor A due to the three currents IA, IB and IC can be written as psi A is equal to 2 into 10 to the power minus 7. So we have three terms. We wrote this expression from the generalized equation of a composite conductor lines. Psi n is equal to 2 into 10 to the power minus 7 summation P is equal to 1 to n IP ln of 1 by d np. Okay, so here n is equal to A. P is A, B and C. Okay, so the first term corresponds to P is equal to A. Okay, and for all the three terms n will be equal to A. Okay, so P is equal to A, so IP is IA ln 1 by d AA np AA plus second term corresponds to P is equal to B, IB ln 1 by d AB plus IC. The third term for P is equal to C, IC ln 1 by d AC. Okay, so hope you understood how we expand this general equation. So P is equal to A, B, C and here n is A. Okay, so for all the three terms we have n is A. P will be A for the first term, P will be B for the second term and P is equal to C for the third term. Okay, so now what is DAA? The geometric mean radius of the conductor itself. So R dash. Then what is DAB? We have taken DAB as D12, the distance between the conductors 1 and 2. DAC is D31. Okay. So after writing the flux linkage of conductor A, inductance of conductor A is LA is equal to psi A by IA. So 2 into 10 to the power minus 7 ln of 1 by R dash. IA is taken outside. Okay, to the left hand side because LA is equal to psi A by IA. So when you remove IA here, ln 1 by R dash. So here it will get divided by IA. IB by IA ln 1 by D12 plus IC by IA ln 1 by D31. Okay, so now we are going to obtain some expressions for this IB by IA and IC by IA ratio. Okay, so we know for a three-phase balance system, the magnitudes of the currents in the three phases will be the same. Okay, and the phase angle between the phases will be, phase currents will be 120 degrees for ABC phase sequence. Okay, so by considering IA as the reference phasor and by taking the phasor along the positive anti-clockwise direction of rotation, we have drawn IB behind IA by 120 degree and IC behind IB by 120 or behind IA by 240. Okay. So from this phasor diagram we write IA is IA angle 0 degree because IA is taken as the reference. Okay. Then IB. So IB, if you take along the anti-clockwise direction, IB is behind IA by 120 degree. So we write IA angle minus 120, or if you take along this direction, IB is, if you take along the clockwise direction, IB is ahead of IA by 240. Okay, so we can write IB as IA angle minus 120 or IA angle 240 degree. In the same way, IC is lagging behind IA by minus 240, or we can say it is leading IA by 120. So we write IC as IA angle 120 and IA or IA angle minus 240. Okay. So for a three-phase balance system, the magnitudes of currents in all the three phases will be the same, but they differ mutually from each other by an angle of 120 degrees. Okay. So in the equation whatever we have derived in the previous step, we need these two ratios, IB by IA and IC by IA. Okay. So from this equations, IB by IA is 1 angle 240. IB by IA is 1 angle 240 and IC by IA is 1 angle 120. So we can expand this as cos of 240 plus j sin 240, which is minus 1 by 2 minus j root 3 by 2, and 1 angle 120 is cos 120 plus j sin 120, which is minus 1 by 2 plus j root 3 by 2. So now we substitute this IB by IA and IC by IA in the previous equation. Okay. So inductance of conductor A is LA is equal to 2 into 10 to the power minus 7 ln 1 by R dash plus IB by IA we have substituted. Okay, this term is IB by IA minus 1 by 2 minus j root 3 by 2, and this term is IC by IA. We substituted for IC by IA. Okay, so now you expand minus 1 by 2 ln 1 by d12 minus, this term, then minus 1 by 2 ln d 1 by 31, then this term minus j root 3 by 2 ln 1 by d12 plus j root 3 by 2 ln 1 by d31. Okay, so we expand this two terms into 4 terms. Okay, so now what we are doing is we are grouping. So we take this two terms. Okay, so we have minus sign here, here also minus sign. So when you take this d12 to the numerator, this minus will become plus. Similarly, this d31 when you take to the numerator, this minus will become plus. Okay, so now it will be like 1 by 2 ln d12 plus 1 by 2 ln d31. So addition of natural logarithm will be like ln of d12 into d31. Okay, then this 1 by 2 can be taken to the power. Okay, so this is the simplification of these two terms, ln of d12 d31 the power 1 by 2. In the same way, we have simplified this to combine these two terms also. J root 3 we have retained. Okay, then d12 has gone to the numerator as after changing the sign as plus, then this d31 in the denominator. So this 1 by 2 has gone as power 1 by 2. Okay, so now again we have 1 by 2 we have written as square root, both are one and the same. So 2 into 10 to the power minus 7 ln 1 by r dash plus ln root of d12 d31 plus j root 3 ln square root of d12 d31. Okay, so now these two terms are combined. Okay, so ln of square root of d12 d31 divided by r dash. So this is the inductance of conductor A. In the same way, we are going to derive the flux linkage of conductor B due to the three currents. Okay, so flux linkage of conductor B, psi B. So here what is N? N is B, the second conductor B. What is P? A, B, C. Okay, so we have again three terms. First term corresponds to P is equal to A, P is equal to B, P is equal to C, and N remains the same. N is equal to B in all the three terms. So P is equal to A, IA ln 1 by dBA, IB ln 1 by dBB plus IC ln 1 by dCB or dBC, both are one and the same. Then what is DAB? D12. What is DBB? R dash. What is DBC? D23. Okay. So now again what is psi LB, inductance of conductor B? LB is equal to psi B by IB, which is 2 into 10 to the power minus 7 IA by IB ln 1 by D12 plus ln 1 by R dash plus IC by IB ln 1 by D23. So now we need the ratio IA by IB and IC by IB. Okay. So initially along with the phasor diagram we have written IA, IB, IC. Okay. In terms of the phase angle. So now from those three relations we write IA by IB, IC by IB. Okay, so in terms of cos and sine you are writing, and you will get the complex form of IA by IB and IC by IB. So now substitute IA by IB and IC by IB from these two equations in this equation. Okay, so now LB is equal to 2 into 10 to the power minus 7. This expand it and you will get 2 terms, and this keep as such. This also you will get 2 terms. Okay, then this 1 by 2 ln 1 by 2 and this 1 by 2 ln d2 3 you combine. Okay, so this term and this term should be combined. Similarly, this j root 3 term and this j root 3 term should be combined as shown in this step. Now combine these 2 terms. You will get the expression for LB. C equal to 2 into 10 to the power minus 7 ln of square root d1 to d23 by r dash plus j root 3 ln square root of d23 by d12 Henry per meter. Okay, so now check the expression for LB with LA. So it is not the same. Okay, so LB and LA are different. When you substitute the values of the distances, radius and everything, you will get different values for LA and LB. In the same way, we are going to derive for LC, flux linkage of conductor C due to the 3 currents. Psi C is equal to, again we have 3 terms. So first term P is equal to A, second term P is equal to B, third term P is equal to C. Okay, so in the first term P is replaced by A, IA ln D1 by DAC plus IB ln 1 by DBC plus IC ln 1 by DCC. Okay, so now substitute for DAC is D31, DBC is D23, DCC is R dash. Now inductance of conductor C is LC is psi C by IC. So you will get IA by IC ratio, IB by IC. Then from the phasor diagram we have written few relations for IA, IB, IC in terms of the phase angles. So from that you write down the expression for IA by IC and IB by IC. So when you take one angle minus 120, it is equal to minus 1 by 2 minus j root 3 by 2. Okay, so now these 2 equations you are going to substitute in this ratios, IA by IC and IB by IC. Okay, so now LC, in LC you expand this term into 2 terms and this term also can be split up into 2 terms. Okay, again you can see you will get 1 by 2 ln d31, here also 1 by 2 ln d23. Combine both as ln d31 d23. Okay, so 1 by 2 ln d31 d23 will become as ln of square root of d31 d23. In the same way, this term and this term can be combined like this. So now you will get LC as 2 into 10 to the power minus 7 ln root of d31 d23 by r dash plus j root 3 ln square root of d31 by d23 Henry per meter. So we have summarized and written the expression for the 3 inductances of conductors A, B and C, LA, LB and LC. Okay, so we have seen the inductances of the 3 conductors depends upon the unequal distances between the conductors. So if the distances are unequal, we will not get the same value for LA, LB and LC. Okay, and since the inductance of all the 3 conductors are not the same, you cannot expect same voltage drop across the 3 lines. Okay, so the voltage drop also will be different. So in this LA, LB and LC, there is something called as J term, imaginary term. So this imaginary term represents the exchange of energy between the phases. Okay, so wherever the inductance value is more, it should exchange its energy with the conductor having less inductance.